Okay, let's give you guys some more practice. So somehow integrate this from 0 to pi over 4. So press pause and have a go. Okay, so to do this, visualize this as being one block multiplying with another block. Well, tan theta is really sine theta over cos theta. So tan squared would be this. So we can put this into here. So this thing here would then become this. So now cos squared will cancel out with cos squared. That would give you sine squared. So that will give you sine squared. So every time you want to integrate, we've done this many times. Every time you want to integrate sine squared, you've got to think about this. And every time you want to integrate cos squared or theta, then you've got to think about this. So in this case, we want to integrate sine squared. So put this into here. So that will then take us to here. Factor out the half. So that will then take us to here. Integrate this. It will then give you this. And we've done this many times. So it's blah blah blah. The final answer is this. Okay. So next one. So here somehow integrate this. So press pause and have a go. Okay. So to do so when you want to integrate something, try to keep an eye out for something being the derivative of another thing. So for example, if you look at this thing here, so this is the same as this, but the thing is, try to keep an eye out for something being near enough the derivative of another thing. So if you look at this x here, now when you differentiate this bubble here, it will give you minus 2x. You see this x here matches up with this x here. We can make the adjustment for this negative 2 later on. But the point is, when you integrate something, try to keep an eye out for something being near enough the derivative of another thing. So this thing here is near enough the derivative of this bubble here, and then this bubble here is the same as this bubble here. So really, when you look at this thing here, you should make this to be your substitution. You should make this to be your substitution. So let u equals that thing there. So if u equals this thing here, differentiate both sides. That will then take you to this. You ultimately want to replace this dx here. So rearrange this to make dx a subject. So dx equals this thing here. So now we can put this into the dx. The u here, we can put it into this bubble here. And then this bubble here, we can put the u into here. Okay, and then because this is near enough the derivative of this bubble here, later on this x will cancel out. This x here will cancel out with this x here. Okay, well, substitute everything in there. That will then take you to this stage here. So now this x will cancel out with this x. Factor out the negative a half. So that will factor out the negative a half, and then that will then give you this. So this here, you're still going to have trouble integrating this. You probably have to stare at this for a long time in order to integrate it. But if you make this substitution, it will make life a lot easier. So if v equals this, so our normal routine would be to make this to be our substitution, differentiate both sides, and then ultimately we want to replace the du. So we want to make du the subject, or du equals this thing here. So we could put this into here, okay, and then we got to ask ourselves, what's u? Well, we would look back to this. Well, if v equals the square root of u, then u must be v squared. So we can put v squared into here, and then what's this thing here? Well, this thing here is actually v, so we can put it into here. But rather than doing this, once you've made this substitution, here's an alternative way. You can immediately jump to this, and then from here, differentiate both sides. That will then give you this, and then now du is already on its own. So we can put this into the du here, and u here, it's actually v squared. So we can put it into here, and then this v here is this thing here. So it's up to you how you do it. But if from here you could jump to here, and then from here you could jump to here, or starting from hang on, bear with me, or starting from here, hang on, or starting from here you can jump to here, and then from here you can jump to this. Use these, well, use whichever way you want. This way seems to be neater. Well, anyway, substitute everything into here, then it will become this. So now this 2 will cancel out with the 2 here, giving you a -1, and then factor out the v here, and then these 2 will cancel out, giving you this. So now integrating this is nice and simple now. So integrate this. It's we've done this many times, that's why it's simple. So integrate this, it will give you this. And then earlier we said let v be square root of u. So so we can put the square root into the v here, and then that would then take us to here. And then earlier we said let u be this. So we can put this into the u here, giving you this. Okay, giving you this. But then if you get a graph plotter and plot this, if you get a graph plotter and plot this here, it will look something like this. It's always positive. Now positive plus another positive, it will always be a positive. So we don't really need the absolutes here. We can just keep it simple and just use brackets. Okay. So this is your final answer.